We're going to get started with section 2.2. The I can statement is I can solve systems. So let's write systems of equations by graphing. So the technique we're going to review today is solving systems of equations by graphing. Quick couple of warm-up questions here. If a point works in the blank, then it's on the blank. If a point works in the equation, then it's on the graph of that equation. And by the same token, if a point is on the graph, then it works in the equation. Okay, so those two things are related, just like we've talked about before. A graph is a blank of all the points that work in the blank. A graph is a picture of all the points that work in the equation. Good thing to keep in mind. A graph is a picture of all the points that work in the equation. And then a quick review of some stuff that you've seen before. You've talked about linear equations in other classes. Y equals a number is either a horizontal or a vertical line, and the other one is x equals a number is either a horizontal or vertical line. You do not want to mess these up. You got to make sure that you have these straight. Y equals a number is actually a horizontal line. Now I realize the y-axis runs vertically, it runs up and down, okay, but remember y equals a number tells us where it crosses the y-axis, so it's going to slice across the y-axis. It's going to do that in a horizontal fashion. That means x equals a number is a vertical line. Good thing to keep in mind, so let's make sure we do that. Now when we solve a system of equations, what we're doing is we're finding a point that works in both equations at the same time. And graphing is by far the most basic way to do that, but it can be a bit of a hassle, and it's not always going to give us the exact answer. It's not a very precise way of doing things. We've got to graph things perfectly. We've got to hope that the two lines cross at a nice point and nice convenient integer values and things like that. So it can be a bit of a hassle, but it's a good way to get started here. So we're going to go ahead and do these. You'll notice that I've got these color coded in example 1. I've got this one in red and that one in blue. So we're going to go ahead and graph this one. This one's already in slope-intercept form. Crosses the y-axis at 4, has a slope of 3/2, so we're going to rise 3 and run 2. Going the other way, down 3 and back 2, down 3 and back 2. So we just kind of follow that stair-step pattern. Draw that as straight as we can. Would be a good idea if you've got a straight edge or something that you can make a nice straight line with if you did that. And then on this one crosses at -2, so this one crosses right here, and the slope of this one is -3/2. So this would be down 3 and run 2, down 3 and run 2. You'll notice that we're expecting it to have a negative slope. It needs to go down from left to right, so we're in good shape there. The opposite of going down 3 and right 2 would be up 3 and back 2, up 3 and back 2, up 3 and back 2, so we get that right there. Again, as straight as you possibly can there, so we can be nice and accurate. On this particular one, you'll notice that it crosses at this nice point right there. That point was on both of those. So that means that is the solution. It's on the red graph, it's on the blue graph, it's on both of them at the same time, so it's a solution. It would work in both equations at the same time. So this is going to be the point -2, 1. We always write that as an ordered pair. All right. Now don't forget, we can use these words right here. We want to describe this using the words consistent, inconsistent, and independent and dependent. Okay, so this one right here, because it has an answer, it's got to be consistent. So we're going to write this one down as consistent. And because it's got just one solution, not an infinite number of solutions, it's going to be independent. So this one's going to be consistent and independent. All right, so that's the other part of the answer. We've got the solution, and then we also want to just practice using our vocabulary words there. Okay, let's check this next one. You'll notice that here, this is not in slope-intercept form, so we've got to move this around. Now, once you practice this enough, you'll get pretty good at doing this very quickly. So I'm going to have the 2y here. If we move that over to the other side, that's going to be a -3x, and then of course that's a +4. And then we're going to divide everything by 2. And then we'll simplify. So the red one is going to be y equals, this is going to be -3/2 x plus 2. And then we're going to take the blue one and we're going to solve that one. So let's see, I'm going to move that to the other side. So this is going to be -2y equals, we do that by adding. So this would be adding x, so that'd be a +x over there plus 4. And then we're going to divide everything by -2. So that means we'd have y equals, this would be a -1/2 x, and then that would be a -2. So we're going to graph each one of these. So let me go back and do the red one. So this is going to cross at 2, and it's going to have a slope of -3/2. So we're going to go down 3 and over 2, down 3 and over 2, down 3 and over 2. we want to do enough of this stair-step pattern that we get a good idea of what this looks like. Remember, these are all those distinct points, those discrete points, but the graph is actually this continuous set of points that goes from one end to the other, and then we put that arrow on there. So then we're going to do the other one. This one crosses at -2 and has a slope of -1/2. So we're going to go down 1 and over 2, down 1 and over 2. You can kind of see what the answer is already. We'll just follow this stair-step pattern, and we'll make a nice straight line, as straight as we possibly can. Put arrows on the end, so it's all those continuous points in that nice straight line. And then we've got a solution here. The solution is this point right here. So that's going to be 4, -4. It is also consistent and independent. All right. Now, how can we check our answer? We can check our answer because remember in the warm-up question, it said if a point is on the graph, then it works in the equation. If it works in the equation, then it's on the graph. Well, this point should work in both of those equations, so it should make both of those equations true. I'm not going to take the time to do that, but what we could do is we could plug it into both equations. So let's just write plug it into both equations. Plug it into both equations. Should make them true, like we talked about before, what a solution means. Okay, let's take a look at these couple right here. We've got example 3 and 4. You'll notice that example 3 already in slope-intercept form, so that's always nice when they do that for us. So let's go ahead and graph this. This one crosses at -1, has a slope of +3/4, so we're going to go up 3 and over 4, up 3 and over 4. Follow that stair-step pattern. The opposite would be going down 3 and back 4, down 3 and back 4. So it looks like this. Straight as we possibly can. Put those arrows on there. And then the blue one crosses at 1, and it also has a slope of 3/4. So we're going to rise 3 and run 4. Rise 3 and run 4. Go down 3 and back 4, down 3 and back 4. So it looks like this. So you'll notice that what we have here are two parallel lines. These are never going to cross. So what we get here is we get no solution. Now the cool thing about this is we do have some vocabulary for this. Consistent meant it had an answer, had at least one answer, maybe infinitely many. And then inconsistent means it does not have an answer at all. So we can summarize this whole thing. Instead of just saying no solution, we can say this is inconsistent. It's an inconsistent system. It doesn't have an answer. There's nothing that makes both of the equations true at the same time. The lines do not cross. Okay, look at the next one. We've got y equals 3x plus 5. So this is going to cross at 5, which is right there. Slope of 3, 3 over 1. So rise 3, run 1. Can only do one dot there. So let's go down 3 and back 1, down 3 and back 1. Again, we should be really good at graphing these at this point. Always a good idea to use a straight edge so you can make that as straight as possible. And then the next one up here is y equals -4. This is a horizontal line. Remember, y equals a number tells us it crosses which axis? It crosses the y-axis at -4 and would go like this. Horizontal line just like that. Whoops, not quite as straight as I could have made it. So this is the solution right there. So that means we've got the point. This would be -3, -4. So this would be -3, -4. No surprise that the y coordinate is -4 because that's the only y values that would make that one true. So there's our solution there, and this again is consistent and independent. All right, so we'll go ahead and circle that answer. All right, you should be able to rate yourself on how well you understand this, but I do want to go through and run through a little thought experiment here. It says, what if the system looked like either of these? So if we had y equals 3 and y equals -4, well, let's think about that. If we had y equals 3, that would be a horizontal line at y equals 3, so it would look like this. And if we had y equals -4, it would look like this. So we're going to have no solution to that one. This is going to be inconsistent. Inconsistent right there. And what if we had this? So let me draw a little set of axes right here. And if we had x equals 2, remember x equals a number is a vertical line. It tells us it crosses the x-axis at 2. So we go over here 2. It's going to cross there. It's going to slice right through there, be parallel to the y-axis. And then the other one is y equals 1. So that would be a horizontal line. Well, they would cross right there, so that means we'd have a solution. This is going to be consistent, and it's going to be independent. So we'll write independent. Not that you have to write that on every single one of those. Mostly what we're interested in is what is the solution? What makes both of those true? Well, on this one, it has an x-coordinate of 2 and a y-coordinate of 1. And again, that should be no surprise because the only x-coordinate that would make this one true is a 2, and the only y-coordinate that would make this one true is a 1. So we've got 2, 1. So there's our answer on that one. All right, good luck on the assignment.